Okay, well, hopefully everyone can hear us and see us loud and clear. My name is Chris Jones, and I'm the current president of the Australian Electric Vehicle Association, and welcome to our first webinar for 2024. As I mentioned earlier, we're hoping to have about 10 of these this year, roughly one a month. There will be a time where we won't have webinars, and that will be during the conference and EV Expo lead up. We're obviously going to be a bit preoccupied with that. But yeah, we're going to try and have about 10 this year. So I thought I'd first of all acknowledge that we are sitting, most of us are sitting, some of us are standing, sitting on Indigenous land. And I'd like to pay my respects to elders past, present and emerging. It's always worth getting to know the names of things in your local mob's dialect. I think that's just the least we can do for the people who are here first. A little bit about the Australian Electric Vehicle Association. We are actually the world's longest continuously running EV society, where we just clocked up 50 years of existence last year. And it's been a real sort of a breakthrough year for us too as well in terms of EVs coming into the market, technologies coming along, and our organisation is maturing as well. So some really exciting things coming up on the horizon. We kind of represent the end user, the consumer of the EV world. Obviously, there's plenty of good representation out there for the industry, but our goal is to try and bring that technology to the people, and that's through things like this webinar, as well as test drives, expos, and information. So we've got our 4 speakers today. We've got Bryce Gaton, who's an AEVA member in Victoria, but he's also runs a consultancy called EV Choice. We have Xavier Pena from Wallbox, who is a charge point operator, charge point installer and retailer. We've got Sanjay from Car Chargers, and Sanjay has been specializing in strata and multi-unit dwelling EV charging options. And we have Robert Wilson from Energy Queensland, basically the network that runs charging in Queensland. I've just been notified that my internet is a bit flaky.
Chris, if you can hear me, you dropped out. If you'd like me to pick up and start with the presentation, just nod your head. Your video's come back up again.
Yes.
Oh, good. You're back up again. Sorry, you froze for a moment. Just thought I'd better let you know, and the participants know we haven't all died at once. Shall I make a start, Chris?
Yes, please do. Yeah.
Yep. That'll probably get over the slight flakiness. Yes, just a quick thank you to Chris for that very nice introduction, and apologies to all for that slightly flaky internet there. Hopefully we won't get any more interruptions on the way. I'm going to do a quick intro to the session, and then we've got 3 really good speakers tonight talking about on the specific aspects of the stuff that I'm just sort of doing the definitions of. So I'll start with a share screen, and hopefully I'll manage to actually hit the right button. Share screen. Let's see if I can just get everybody to... Chris, would you like to nod to say that you can see that? Beautiful. Okay, just a quick introduction, and should take me 10 minutes or less to do it. A quick little thing. I'll start off on first my little... what is an EV? Just an EV 101. We're talking about the plug-in electric vehicles tonight. That's your BEV, that's BEV, the battery electric vehicle, and they're the ones that'll be involved in the charging that we're talking about tonight. That's because the plug-in hybrids there that you see, yes, they do have the same plugs, but they generally have a small battery, and even on a power point will charge in 2 to 4 hours, as you'll see soon. The next one along is your hybrid electric vehicle, and there your Priuses, the Toyota Camrys, that type of one. They'll let you in a secret when the bans come in overseas on the sale of internal combustion engine vehicles. Whilst the PHEVs and the BEVs make it across, the HEVs are included in the ban, so we'll see those end in manufacture overseas. And of course, I bring in the fuel cell electric vehicle, or the hydrogen car as it's called. I think 6 of those came into Australia last year, none of which were sold. They're actually all leased. I think it's pretty much accepted that they won't have a role in passenger vehicles, but you will hear about them occasionally still. So that's the 4 types of electric vehicles around at the moment. The next step is, how do you refuel an EV? And we're used to that model, a within trip, going out of our way, stopping and refueling. So as part of the trip, we may take time out, sometimes even detour to do it. When it comes to an EV, we're doing this. We have a destination charging model. It's a very different way of thinking about refueling, so to speak, your car. Because a destination is where you get your car refueled. So there really is no time out for recharging, unless you're doing a Melbourne to Sydney trip like I will be next week, in which case I'll be stopping at DC chargers along the way. But otherwise, it's just you pick your charging speed to suit where you're parked, and you just do your thing while your car does its. So that's the big change in coming to EVs and their refueling. To refuel them, I keep calling it refueling, but it's actually recharging, use an EVSE, electric vehicle supply equipment, otherwise known as a car charger. Those first two on your left there are plug-in ones. Most manufacturers actually give you a plug-in one to come with the car, except Tesla and a couple of others who are getting a little bit cheapskate these days and don't include them. They don't cost a great deal, $300 to $500 is a typical one if you don't get one with the car, but most cars come with one. And they'll charge, as you'll see soon, slowly, but if you don't do many Ks, that's pretty much all you'll need. The bottom one there is if you're going off the beaten DC fast charger track, that's a really handy one. It plugs into a 32 amp three-phase outlet and it'll charge your car to its maximum. But yeah, you don't normally buy one of those unless you sort of do a bit of a Leyland Brothers job. This is what we'll be talking about tonight, is your hardwired chargers. On your left there is what's called a BYO lead charger or socket charger. Councils and public chargers love those because they don't have to look after leads. Tesla, one shown there, is a tethered lead, really good for home use. I generally recommend buying a charger with a tethered lead if it's for home use, because it's just that much more convenient to roll it up and throw it on. The key thing is with public chargers, they get quite damaged, and I pulled up to some old AC Tesla destination chargers with some very dodgy leads, because like the leads that you use for pumping up your tyres, they cop a bit of a hammering. And then we won't be talking about these tonight, but just to finish the picture is your DC fast chargers, and they can charge 150 times or more faster than a PowerPoint. But that's, your within trip fuel bowser like replacement. They don't get used a lot, but when you do, they're very handy. So we're now thinking about charging speeds, and this is what we'll talk about more about tonight. That first line in red on the left, 1.8 kilowatts or 12 kilometers charged an hour. That's what a PowerPoint will do. So if you're doing 50 Ks, 100 Ks in a week, maybe a PowerPoint's all you need. If you're traveling around and you stop at a caravan park, 15 amp PowerPoint, you'll get roughly 24 Ks charged an hour. That will probably give you an 20 to 100% charge overnight and on your way. And I've done that many a time on my trips around. Tonight, though, we'll be talking about the home chargers on the left, down the bottom left there, and then you can have single phase, and they can do 7.4 kilowatt maximum or 48, 50-ish kilometers charged an hour. If you've got three phase at home, which is fairly unusual, but if you do, you've got a bit of a charging jackpot there, and you can do 11 or 22, depending on how fast your car can charge and how much supply you have. And just to give you a bit of an example, if you're wanting to use the DC fast chargers, the fastest there will do 2.6 minutes for 100 Ks. So you're looking at 10, 15 minutes if you're doing a 30 to 80% charge for a stop. And for your long distance trips, intercity trips, that's probably about the right time to stop anyway. And that's every 2 to 4 hours, depending on when you want to stop. Coming back to that question of how fast you need to charge at home, PowerPoint, as I said, if you're doing less than 100 Ks a day, 12 kilometers charged an hour, less than 8 hours will have you charged away again. So you go to sleep, you'll be going in the morning. That will cost you about $500 up. I'm an electrician by background, and that's the sort of numbers if it's nearby the switchboard. By the way, I do recommend not using extension leads with portable chargers unless you've got a really good screw together seal up one. That's one charging event with a BMW i3 that killed that plug-in socket. Within range of one car, the Wallbox type ones that we talked about tonight, or any EVSE that's a hardwired one, I can get a full charge if I want to do 0 to 100% with one of those. And most cars will do it overnight, even on single phase. And they start the very cheapest, about $700, $800 up to an all singing, all dancing one that has all the smarts in it. They'll talk about in a minute. By the way, I keep mentioning, people keep worrying about plugs and, waiting for the right plug. That's the Australian plug. That's all but two cars come in with that combination. And the only ones that don't are actually old models about to be superseded. And still come in with that same AC plug, so they can all charge with the same plug at home. If you bring in a Japanese import, to the Japanese ones, they come in with that. but that is not the standard Australian set of plugs now. And in North America, they use that particular plug, but they have a funny 120, 240 volt system, two-phase, and that plug can't really be used anywhere else. So that's confined to North America. So the plug war, as I've said, is over. Now, we're going to becoming trend, and I'm sure Xavier will talk a lot more about this, as your vehicle to loads and your vehicle to X, vehicle to something. Vehicle to load, that's for the Chatamo, the old DC plug is the DC, and you had to buy a $5,000-ish box to get your AC for a CCS system. That's that adapter there that plugs in. If they don't come with a car, which they commonly do, they're maybe a couple of $100 to buy. Vehicle to home or vehicle to building, and vehicle to grid, which is the next layer up where you can get power out of the car and into the grid itself. They're done via the DC plug still, same as the Chatamo. And Xavier will talk a lot more about them. Currently, Chatamo, as I said, does it. Chatamo lost the plug war though. CCS is being developed to do all of those things. Many of them do V2L now. CCS cars are starting to arrive, and we'll have that functionality built in. And then the CCS systems to be installed will be, depending on Australian standards acceptance, which will be talked about a bit later. So maybe 2025, we can start installing that. This is the duct curve. You know, when's the best time to charge? It was basically when there's lots of solar in the belly of that duct there. And the key point of that is the EVs are a perfect thing for soaking up that belly of the duct. So some of the supply authorities are already starting to give you some really good tariffs, and that's 8.2 cents, 9 a.m. to 3 p.m. in WA there, and 51 cents if you really wanted to charge during the peak. I'm sure our Ergon Energex speaker will actually come up with some numbers on what they're doing. So installing chargers, could end up with an unhappy customer, blown suppliers. Not really all that simple if you wanted it to just be plug and play. Not future-proofing. These are all the sort of things that I teach electricians about in the new course that's been developed. You could end up with an overpriced quote if they particularly insist on sticking to a calculated maximum demand. Part of the course that's coming up, or is actually being rolled out, is that most of the time you don't need to upgrade the power supply. So if the electrician says that, get another quote. Probably they're just being a bit cautious, or they're not quite sure what they're doing. And if you're not doing it properly, you could end up with an unhappy grid too. So you could end up with overloads, not plugging in the neck of that duct instead of the belly, not matching a charger with excess renewable generation, again, plugging in and all getting the charger done automatically turn on when there's that belly of the duct. And excess generation capacity if the EV transition's not managed well and they add all this extra supply when people aren't doing it. And that's what I'm about to talk about next, is your models. You have your dumb chargers, like your PowerPoints and things that are used. That's pretty much what you're doing now, very dumb chargers. You have your smart-ish chargers, which you can buy now. And they do a whole lot of things behind the meter, which Xavier will talk about. And coming up soon will be the fully smart charger, which is basically those smart-ish ones, but they can actually start being talked to by the grid, which will be talked about a bit later as well. And there's a link there for an ad, the Driven. I'm not doing an ad. I was trying to Freudian slip there, not trying to do an ad for the Driven. As I mentioned, there is a new course coming up. It is a accredited course, so it can be run by any TAFE. They can pick that up. That's the course number. And what we're doing in that, I was part of the course development team. We teach electricians about EVs and EVSEs. We get them to do a site assessment design solution process, and we get them to test and commission it and actually properly check them out. So that's the very brief background on EVs and EVSEs. I'll throw over to the rest because the burning questions can wait till the end, I think. And I'll unshare my screen and let Xavier begin his.
Oh, thank you very much, Bryce. And yes, as Bryce said, please, if you've got any questions, just put them into the Q&A box, and we'll try and get to them at the end of our presentations. I'll try and answer some of the quick ones by typing them in if I can. But yeah, over to you, Xavier.
Fantastic. Thanks a lot, Chris and Brice. Excellent presentation. Hello, everyone. Thanks for having me tonight. I'm going to share my screen. And as you please to nod your heads if you can see it correctly. Excellent. Good stuff. So yeah, my name is Xavier. Been to Australia since the beginning of 2023. As you can tell by the accent, I come from Spain, as Wallbox does. It's a company that started back in 2015, and we've been in Australia since 2018, thanks to different distributors like JetCharge or One Stop Warehouse. Basically, what I would like to cover today is a couple of things. Bryce has already alluded to the smartish chargers. This is what the business that we are currently in. Obviously, there are many other competitors in the market, and we encourage you always to check their benefits and features and pick the one that is more suitable for your needs. And then obviously I'll also touch base. I would like to give you an update on the status of the upcoming technology related to bidirectional charging. Starting though with the smartest chargers, you might be wondering, is it really worth investing the extra money that these smartest chargers cost? Again, it really depends on your needs, right? So Wallbox basically manufactures everything that we sell in Australia and New Zealand in Barcelona, my hometown in Spain. It comes with 3 years warranty, and we cover all the needs in the EV charging market, from the residential use to commercial applications like fleets or shared buildings or workplace, and then also the public chargers that you can see on the right-hand side with Supernova, which is our DC fast charger. We have implemented 5 of them so far in Australia, and hopefully many more to come in 2024. But as I said, the key difference of these smartest chargers are these energy management solutions that you can apply at home. And I'm going to cover them really quickly. By all means, drop some questions. We'll look into them later. But the first one is dynamic load balancing. This smart feature is something that you can enable thanks to the installation of an energy meter in your main switchboard that is connected via communication cable with our charger. Basically, what this is enabling is reading the total capacity or the total current that can be executed at your place. Normally, Australian homes have a capacity of around 63 amps. So this means that if you have your induction, your air conditioning, your pump for the pool on, everything on at the same time, and then you start charging your electric vehicle, which normally runs at 32 amps, there is the possibility that you exceed these 63 amps. What dynamic load balancing does is ensuring that this limit is never exceeded. And if you have lots of appliances on, it will automatically derate the charger, so you never exceed that limit. The moment that you turn off all the other appliances, the charger will, or the meter actually, will automatically detect that and intelligently pump up the charge through the charger, so you can charge at the fastest possible speed without tripping your fuse. So it's kind of a peace of mind. The other smart feature that you can enable with our chargers and other smart chargers in the market is dynamic power sharing. So basically, what this is doing is monitoring the available power in a building. It can be like a shared building, a workplace, or your home as well, if you have 2 EVs, for example, and then dynamically distributing the power in that electricity line between the 2 vehicles. With Wallbox chargers, you can daisy chain up to 100 chargers. There are very little cases like this, but hopefully in the future. And it's something that you can scale. You can start only with 2 chargers or 3 chargers, for example, in a workplace or in a shared car park in a big strata building, and then add others to that daisy chain in the future. So as I said, up to 100 of them, dynamically sharing the power available in a single power line among the different EVs connected. The moment that one EV drives out of the car spot and disconnects from the charge, obviously the meter will identify that and automatically distribute the available power among the remaining connected EVs. And last but not least, the last smart feature I wanted to talk about is obviously solar EV charging. In Australia, it's amazing. It's over 40% of households have access to solar, and this number is increasing every year. So definitely this, the installation of the energy meter coupled with the EV charger allows you to use this excess solar to charge your car. Now, some people complain sometimes like, hey, I did the installation, I set it up on the settings of the app, everything is appropriately connected, but the app is telling me that it's still pulling some electricity from the grid. That's possible. So basically an onboard battery in the EV requires at least 6 amps to start charging. If you don't have enough solar energy to deliver these 6 amps, there is the possibility that the app automatically tops up that electricity from the grid. But thanks to our app, if you want to limit that option and only limit to green charging or only using solar, it will only do so when you exceed this 6 amps available, which is relatively easy to achieve. All right, this covers the energy management solutions. I also encourage everyone to take a look at the smarts of the apps and the desktop applications that not only Wallbox, but other EVSE manufacturers deliver. In this case, obviously, I'm representing Wallbox, so you have here the screenshots from our app on the left-hand side. As you can see, you can monitor at all times your charging sessions. You can schedule them manually at this stage. Hopefully, we will become soon a fully smart charger and read them automatically. And monitor basically your charging habits and how much you are spending or saving thanks to solar. On the right-hand side, you have my Wallbox portal, which is a business solution. We offer it 100% for free. And imagine you are a fleet manager and managing a network of, say, 30 electric vehicles, and they are being charged at home. On this portal, you can monitor them all, see the status at every single time. It enables your employees to, say, submit an expense report where they are reporting the electricity use for each of the charging sessions. And it also allows you to monetize the charger. Obviously, the fleet with 30 vehicles is like the ideal business case for us. But we see plenty of, say, Airbnbs or people that manage like a stays, and they are installing an EV charger there and monetizing it in order to recover that investment. So thanks to this, my Wallbox portal, you can basically set a price for the kilowatt hour that you consider appropriate and charge people for the use of your charger. Excellent. From here, I would like to stop and basically I'll move to my second topic, which is V2G. In this image, you can see the Mitsubishi headquarters actually in South Australia, in Adelaide, where thanks to JetCharge, one of our longest distributors in Australia, they actually run a trial with ARENA funding to test Quasar 1, which is our first iteration of the V2G technology. We really appreciate these partnerships and obviously this funding to test this type of technology. And this has enabled us to focus on what we believe is the future, which is Quasar 2. Quasar 2 will be available in the US in 2024. We have recently presented a partnership with Kia and EV9, one of their popular EVs that they have released this year, by which the owners of EV9s, the Kia EV9s, they'll have access to the Quasar 2 as well. Obviously, this opens the door to the V2G, V2L, and V2H technologies that Bryce alluded to before. And I can imagine the million-dollar question from all of you is, when is this technology coming to Australia? So from Wallbox side, as you can see here, and you can find it also in the different articles, our technology is ready. Having said that, we definitely need Australian government to speed up the adoption of EVs and approve the fuel efficiency standards. We were expecting the bill to be passed at the end of 2023. That didn't happen. Hopefully in 2024, it will eventuate. This basically what it's going to mean is that we will receive more V2X compatible EVs into the market. And last but not least, there is the Australian standards, of course. The AS 4777 regulates the inverters that are being used, say, for solar equipment, but also the inverter that you would find in a DC bidirectional charger like Quasar. This Australian standard is being updated right now by the Clean Energy Council. Wallbox, in addition to the membership with AEVA, we are also members with the Electric Vehicle Council, and we are supporting as much as we can, providing technical support to update this standard. And we are hoping that it will see the light towards the end of this year. So all in all, our honest prediction is, as Bryce said before, 2025 will be the year. Until then, we will see more and more compatible vehicles coming into the market. I made a list here of the V2G compatible vehicles that I am aware of and put a little Australian flags to those of them already available in Australia. Some of them, they don't have the V2G capability enabled yet. It will probably be a software update. And then some of them that for sure are coming to Australia in 2024, like the Kia EV9, and some of them with the question mark, because we never know. But hopefully more and more will come soon, and we'll have a strong business case to also deliver the Quasar 2 in Australia. I can wait for that. That brings me to the end of the presentation, but I just wanted to let you know, especially for those based in New South Wales, that Wallbox will be exhibiting at the Everything Electric show, previously known as Fully Charged. We will be there between Friday the 9th until Sunday the 11th of February in the Sydney Showgrounds. And as exhibitors, we get a few free tickets. So I would love to actually raffle them today among all of you present in this webinar. The way that I'm going to select the winners, earlier in my presentation, I was referring to our DC fast charger that we have recently launched in Australia. So the first 4 people interested in these tickets that basically post the name of this DC fast charger in the chat, in the comments, I'll be happy to send the free code for the tickets for this event coming up in February. That's all from my side. Thank you all, and I'll check the questions in case there is any for me. Thank you all.
Awesome. Fantastic. Thank you, Xavier. And yes, if you have any questions or responses to get one of those free tickets to get into Fully Charged Live, just put your thoughts in the chat box or in the Q&A. We'll find it. Excellent. That's wonderful. So, of course, the next question is, well, I live in an apartment. What do I do about charging? And it's a very common question, and it's often revolves around how convenient it is to work with your body corporate. But I'll hand over to Sanjay from Car Chargers, who specializes in this kind of stuff, as well as other EV charging equipment. And he can tell us all about it.
Sure. Thanks, Greg, for inviting Car Chargers to the awesome seminar. So a bit of color about Car Chargers. We started in 2019 and we saw early on that getting apartments ready for EV charging is going to be a hard yard. And 30 to 40% of the residents in the country do live in an apartment, and they would need a solution to transition over to electric vehicle. Bit of color about the company. We started in 2019. We are an EPC. We provide both hardware and software. So like say, we'll be single point of contact for the apartment buildings, end-to-end solution. Kind of just moving on to our client list, some of the companies we have worked with, and recently one of our case studies was used by New South Wales government for the EV Building Ready grant, which was roughly $10 million to get some of the buildings ready for EV charging. Now, coming to the question in terms of what is required to get my apartment ready for EV charging, high level, I think it can be done in 2 ways. One is through common power or individual meters. So you see on the right-hand side what your individual meter may look like. This solution usually works for buildings which may have 1 or 2 floors where your meters may be in the basement or on one particular level, and they are easily accessible. The beauty of the solution is it's lower capex to the building. What you need to do is just put in cable trays. The chargers will be directly connected to individual meter of the lot owner. That way there is no billing required. But to an extent, what we have seen is you may still require load management just to make sure that you never exceed the capacity which comes into the building. And as I said, like it's easier to execute. You don't need a billing system because your individual meters will directly bill for that usage. What we see on the other hand is 95% of the buildings require to go through what is a common power solution. So you may have like a 10-floor building where meters may be on individual floors. In that essence, what you're looking to use common circuit, what we call non-essential. This is what on the left-hand side, what you see is the orange board, where it'll be your starting point to derive the power out of it. Then what building has to do is put in EVDBs, distribution boards across the car park, think about how the chargers will be connected to the internet for billing as well as load management. And then also you'll be looking at putting in cable trays so that let's say the non-owner can go from the distribution board to connect a charger in their space. Under this scenario, we will be looking at both billing as well as load management because the power is given by the starter building. Building will be putting up a reference rate in terms of what is the rate for EV charging during peak hours, off-peak hours. They could encourage off-peak hours by putting up a lower rate for kilowatt hours used to the charger. And as I said earlier, it's more suited for high-rise building. And we see like 90 to 95% of the building going through this structure, whereas 5% of the building going through the individual metering structure. Now, in terms of what we encourage buildings to do is start their journey with a feasibility study. What it helps them is look at various options, right? There are companies which can help on conducting a feasible study. We can do that too. Look at what are the various options. What is the high level architecture which will work for the building, right? How much power is available? We encourage buildings to do the proper data logging just to make sure what is the expected scenario based on number of spaces, number of power, amount of power available, what could work and what could not work. Now, and also the feasibility study helps in terms of when you go out to get quotes, you compare them apple to apple, because otherwise different companies may have different solution which may not work, right? And they're not comparable also in that sense. Now, after you have done your feasibility study, you may look at two options at very high level. One is what we call traditional solution, where you have, let's say, a distribution board every X number of car park spaces. You would need cable tray to make them work so that you can take the power from the distribution board to your individual space. And what we also have seen is under this scenario, you have winners and losers. What I mean by that, somebody who's next to the distribution board, they will, let's say, pay $500 to install the charger because it's a shorter cable run. But somebody who's on the further end of the car park, they may have to pay $2,000, $3,000, $4,000 to get the same work done. So you will see winners and losers in that scenario. Also, you need a lot of cable trays. Other option which is available in Australia is flat cable technology, which we brought in, and we have worked with a few buildings to get it across. We have worked with Mirvac also on a 450 apartment building where we have put in flat cable. What it does is it reduces the amount of switchboards you need on day one. So rather than having, let's say, 5 boards, you may the same amount of power can be delivered through flat cable using 2 distribution boards. It also allows you to have uniform pricing. So earlier I kind of alluded about somebody paying lower price and somebody paying higher amount for EV connecting their charger. This would enable building to have firm pricing and concrete pricing and single pricing for irrespective of the distance from the car park. And also the feedback we have received from the market is that it allows faster installation, and the car park also looks cleaner in that sense that you don't have a lot of orange cables and cable trays hanging around in the car park. Also now moving on, in the scenario where you need a billing system and a load management system, you have to connect the charger to the central network. There are 2 options available. One is obviously hardwired. So you use an Ethernet cable to individual chargers to connect them to a load management system and a billing system. What potentially other option is also Wi-Fi. The good quality chargers do have Wi-Fi connectivity, which doesn't drop out. And we haven't frankly seen a lot of dropouts. What also benefits the building from Wi-Fi perspective that you can enable Wi-Fi calling. So let's say if you have 3 or 4 level of car park in the basement, you can use the same Wi-Fi for Wi-Fi calling. So you don't have to take the calls, outside the building itself. Also, what is happening to the market is, let's say Tesla would provide an update every month or so. So you can enable a software update through the same Wi-Fi while your car is charging and it's in the car park. Now coming towards the bit of a risk where there has been some talk in the industry about what happens in case of a fire. Fire trips can be installed. So in that scenario, what would happen if the fire alarm is triggered at all? You can disconnect your distribution boards from the main switchboard using this fire trip. That take care of the fire risk. Also, I think the other topic is about load management system. High level, there are 2 kind of load management system. A little static, which is basically means like we need to control the load to, let's say, 200 amps and distribute it across all the EV chargers 24/7 of the day, versus dynamic, which basically means that you have to control the charging such that you never exceed the total capacity of the building, but optimize charging when other loads are at lower amount, but at the same time slow down kind of when other loads have picked up. Let's say everybody has turned up their ACs on a hot day. Kind of just looking at load management system, you're looking at 3 different kind of high-level, 3 different kind of load management system available in the market. One is on-site hardware load balancer. Then you could have a company-specific cloud-based solution, right? It will probably work with, let's say, 1 or 2 brands. And then the third option available is a cloud-hosted hardware agnostic load balancer. What it means basically means at a very high level, it's hosted on cloud, but it's agnostic to the hardware itself. So you can have, let's say, charger from 10 different brands, and they're working seamlessly together on the same site. They are obviously based on which choice the building makes. There are pros and cons. So going through on-site hardware load balancer, it obviously has a benefit that it potentially has a faster reaction time. If, let's say, everybody turns on their AC at the same time, it potentially can react faster. But we believe that given you can have buffers in terms of not trying to use 100% of the capacity, and let's say keeping 5% as a safeguard, that benefit goes away. And also, even though your load management system can react in milliseconds or like a second, cars may take 5 to 10 seconds to react to that command. What you're looking at from, let's say, downside perspective, you may be limited to a very specific brand of chargers, right? And also, if, let's say, something happens where the system is not operating, you may be looking at a site visit as well as a downtime. And obvious question is, building has paid for that hardware. What happens when the product is not working? Do you have to buy a new hardware, right? Every X number of years. Now, moving on to a cloud-based solution where it's provided by a particular brand. So obviously, the question comes at what happens when the internet is down. What we do encourage the building is having something like an NBN connection, and then with the SIM backup, so that the load management system can always talk to the chargers. Downside of a brand-specific load management system is obviously the vendor lock-in. You have to go with that particular brand throughout your whole car park. And then I think it also gets into the issue where, okay, what happens if that company is not operating in Australia, or is there any user privacy issues with that kind of a solution? Moving on, third choice could be a cloud-hosted hardware load balancer or hardware agnostic load balancer. What it means is it could work with 10, 20 brands. It could work with AC and DC chargers. Most of the solutions do use OCPP smart charging specification. So it's an open protocol. It's not proprietary. And what we have seen is more brands are implementing it, even though it was optional in OCPP. A lot of brands are implementing it now. And it also brings in best of the both world in terms of, like, there is no vendor lock-in. Also, it kind of load balances across multiple different brands. And potentially, it's also a lower cost in terms of you need less hardware on the site. Plus, it could work on Wi-Fi, so you don't have to run a data cable to each and every charger. Now, kind of moving in terms of your traditional versus flat cable solution. This is a picture on the right-hand side in terms of what your traditional solution will be. You'll be looking at in terms of a big distribution board, so that you can run a separate circuit to every charger. There is obviously benefit and some issues with the solution. This is high level what you're looking at in terms of spreading the stations over time. There's no particular strategy. When you do put in more cars, like you have to run a new cable. In this case, like red cars were already connected, green cars come in, you have to run a separate circuit for each one of them. Now we look at flat cable, high level. This in the middle, you look at the cable itself, where it's rather than being a round cable, it has a flat structure to it. It has been used for over 20 years. I think easiest example is conveyor belts. They use flat cables to run motors on the conveyor belts. It has been now used for EV charging with a thicker cable. These are some of the pictures in terms of what a flat cable solution would look like. These are pictures from a project we recently did. So you see flat cable in the middle and then charger being connected. The beauty of the solution is that one ribbon cable on the back wall could cater to a lot more chargers and reduce your cost also. For some apple-to-apple case studies, for few of the buildings we have looked at it, we have seen that total cost can be reduced by somewhere between $500 to $1,000 per space using flat cable. And then obviously question comes in, what happens in the future? So let's say today you can run one cable across your car park, and eventually when you grow, the beauty of the solution is, as in my previous slide, you had only one feeder and you had a flat cable running across your car park. But in the future, you can cut the cable and tie it back to your distribution board, and it doubles the supply every time. So you're not locked into, let's say, 43 kilowatts. Every time you cut the cable, you can double the supply to the building. With that, I think I'll hand it back to you, Chris. Thanks, everyone.
Fantastic. Yeah, thanks, Sanjay. And yeah, really important point there that, body corporates, often the difficulty of getting a charging point installed in a multi-dwelling building is not technical. It's not an engineering problem. It's a getting past the body corporate problem. And
Yes.
someone has left a question in the chat box, which we'll get to afterwards, about some real examples of working through the body corporate and getting it done in the end and what worked. So yeah, on the topic of load sharing and having that dynamic control, we're very lucky to have Robert Wilson from Energy Queensland speaking about controlled loads. There was the timers on my lights at work going off. So I'll throw it over to Robert, and he can tell us about the network's perspective.
Well, good evening, and thank you for the time. I'll do my level best to share my screen, move across. Fingers crossed I can get it done. There we go. Hopefully that should be coming up soon. Can you see my screen? Can you hear me? Can you hear me, Chris? Is that okay, or?
Yes.
Yes, I can hear you.
Robert.
I'm just gesturing as best I can.
Okay, sorry. I've totally lost everybody else on the screen. All I've got is my screen in front of me. So look, thank you again for the opportunity. Yep. So I'm here to talk to you about, just to give you a Queensland perspective on EV charging. And I work for the networks of Ergon and Energy and Energex as the product development manager within Queensland. So if I may, I'll just literally take you through some of our thinking with regards to what our existing charging is, but also within the next month, what our new charging opportunities present as well for Queenslanders. So from a network perspective, our desire is to build for the future EV charging options that provide equity for everybody, and that in that regard will be the same today as it will be in 10 years' time. Everybody gets the same opportunity to charge their EVs reasonably with the network. But also understanding that some of our shortcomings in the past have been not allowing or giving as much access to fast charging as some customers would want, but also not necessarily giving them the access to rooftop solar charging that they have at home as well. So what I'll do is I'll take you through a little bit of scene setting with regards to how we look at EV charging, and then the actual options that are available today and how they're changing on the 21st of February. So just a bit of background. What does an EV charger look like to us with regards to energy and demand? The average Queensland household uses around about 16 kilowatt hours a day. And through our EV Smart Charge research program that finished just over a year ago, we discovered that really over 83% of all vehicles, EVs, were travelling around about 40 kilometres a day. So that's the daily average that we've been using, and that was assimilating to around about between 8 and 10 kilowatt hours, depending upon the individual vehicle. So when you look at that and compare EV charging compared to the daily average household, there's an opportunity to be doubling the consumption in the household to recharge an EV at home. So that's one component to look at. Then the other component is the demand side of things, and just a few comparison opportunities for everybody is air conditioning systems. You can have small split systems or large systems, and hot water. Those are the sorts of things that we're interested in with regards to being high demand or load electrical appliances. And what we can see is that whilst they might have rating labels that are relatively high, they're either inverters and their loads ebb and flow, or that with hot water, you only have short bursts of energy, and this is diversified across the day to give you hot water. Looking at a single phase EV dedicated charger up to 7 kilowatts, that can take about an hour, just over an hour, to put in your 8 to 10 kilowatt hours of replenishment from a day's driving, but that's continuous draw. And so we don't necessarily have the diversification of energy or demand that necessarily other electrical appliances have in the home. So to take you to our charging options that we have today, up to the 21st of February, They're relatively simple, but they do give some opportunity for customers to have faster charging up to 7 kilowatts in the home on single phase. And single phase is probably, I think as Bryce was saying, is predominantly where the customer market is at the moment. Very few customers have 3-phase. So a power point up to, let's say, standard up to 15 amps, which is what most people may have, 10 to 15 amp. You can have everyday charging, so unfettered use of a 10 amp or 15 amp plug. You can access your rooftop solar, and so you can use your renewables there. You can also have, if you really want to get an off-peak tariff, an economy tariff, you can have your EV charging on that as well. That would it doesn't necessarily have to be hardwired. You can also have that in a plug arrangement or power point arrangement. But the load is managed predominantly on a daily basis, and it means it removes the opportunity for access to rooftop solar renewable energy. So that's a bit of a downside, but you get a consistent lower energy price. For the dedicated chargers, so for an EVSE, it's 7 kilowatts. At the moment, the rule is you have to be on an economy or off-peak tariff. And again, the load is managed and no access to rooftop solar. Now, just looking at the daily replenishment of the 8 kilowatt hours a day, what we're saying is an 10 amp power point takes about 4 hours to replenish your 40 kilometer trip. 15 amp, just over 2.5 hours, and a 32 amp charger, your EVSE, literally just over an hour. So we're seeing that EV charging is relatively flexible, and that from that perspective, the opportunity to provide options for customers around flexible management should present themselves. One question that certainly does come up is, so why this requirement to have anything over 20 amps, which is in our energy connections manual? Why do we need to have it managed on a single phase? Well, predominantly our networks have been designed, and I will read through this, but this will be available to you obviously later as well. At peak times, we have each house allocated between 3 and 5 kilowatts as the diversified value per home or demand per home. Now, an EVSE charger rated at 7 kilowatts is therefore a significant increase in household loading. Now, in the second point, you could say today, well, there's so few EVs on the road, does that really make a difference from a network point of view when they're spread around the network? Well, that may be true, but when it comes to mass market picking these up and the rapid uptake of registered EVs in Queensland, it is going a little bit hockey stick at the moment. If you have multiple customers on a single transformer with coincidental 7 kilowatt charging, and that then happens to get combined with a network peak event. We've just had one last week where we've actually had the largest demand on our network, both networks ever. That's going to generate significant network constraints and maybe even fuses blown in local areas, unless there's the opportunity to manage that EV charging and basically help keep the lights on and the air conditioning on that people would want. So there's a rationale with regards to why anything of a large load like an EVSE 7 kilowatt charger, we are looking to have those managed or able to be managed to help us secure networking and basically keep power going to people's homes. So from the 21st of February, what are the changes? Well, everything that is available today will still be available, but what we're also adding is the opportunity for customers to add an EVSE, but have it on a primary tariff, your everyday use tariff, and either in what we've called a basic active load management environment, where we'll put a network device like we would for an economy tariff that allows us to manage the charging of the EV as required. So not on a daily basis like an economy tariff, but only when needed. That also means is that on a primary tariff, you'll be able to, or a general load tariff, you'll be able to access your rooftop solar as well. So what effectively it means is that you'll be getting your EVSE opportunity at 7 kilowatts. You'll be able to get your rooftop charging as well, but on those days when it's absolutely necessary, we'll come asking to curtail your load on EV charging to keep the network safe. Now, as you've seen in the previous slide, if you're going to replenish your daily usage of 40 kilometers or up to 10 kilowatt hours, we're only talking about an hour and a half maximum to replenish it anyway. So the flexibility of EV charging is becoming apparent. Also, what we've introduced, and even though there aren't necessarily any suppliers yet, what we're doing is opening up the opportunity for everyday traffic on a tariff management of EVs on what we call a dynamic load management, which is where we'll be seeking third parties to help us manage EV charging. So you might have Xavier with Wallbox saying, yes, they can supply a service that means that we can have dynamic load control, again, only as required, or load management only as required through Wallbox or any other supplier like that to help us in those days when we absolutely need it. But again, being on a primary or an everyday tariff means that you'll get access to your rooftop solar as well. So we're opening up the opportunity to get rooftop solar renewable energy charging your EVs, but restricting in some respects our access to managing the EV charging to only when we require it rather than on a daily schedule basis. That's predominantly the opportunity that we're introducing from the 21st of February onwards, which is quite a step forward for us that still allows us to ensure that network safety and reliability for customers is top of our list. When it comes to three-phase connected customers, our rarer customer, look, nothing's really changed, in fact, because irrespective of having a dedicated EV charger, an individual EVSE that is on multi-phase connected, you can have up to 22 kilowatts anyway, and we're not looking for energy management or charging management in that scenario, but you're still able to, if you wish, put your EVSE onto an economy tariff to get a lower rate. But again, you remove your ability to necessarily access your rooftop solar. So in a nutshell, that's what we are working towards with regards to release on the 21st of February. There is a little bit more detail that if you really want to get stuck into it, it's available. And we've got some links here on the slide pack where you can go and look for the detail on our website. What we've also done there in the table to make it easy for everybody, rather than going through a 200-odd page document around the Queensland Electricity Connections Manual, is also highlighted those particular sections and clauses that are pertinent to this particular charging opportunity for Queenslanders. That, in a nutshell, is it. I hope I've done relatively well and leave plenty of time for questions.
Fantastic. Thanks for that, Robert. No, you did well on timing. Really good to get all of the perspectives, whether it's a detached home or a multi-unit dwelling, and then to hear from the network what they have planned. Robert, if I could just start with one question to you, and then I'll go to each of. I've got a question for each of the speakers before I start throwing it out to the crowd for speakers there. Obviously, you can speak to the Queensland Network's decision to introduce these arrangements for controlled loads. If I'm not mistaken, Victoria is doing this as well. Are there any other states that are implementing this? And if so, specifically for EV charging or just big loads in general?
Look, I can only really sort of take a Queensland perspective with regards to what we're doing today and the reasons we're doing it for longevity and equity for all customers. Look, the other states have different rationales. They've got different connection standards as well. My understanding is what you did. You potentially wanted someone from Victoria to talk about the same sort of thing. A presumption is that they're also looking at that, but there are multiple DNSPs or network service providers in most states other than South Australia and Western Australia and Queensland. So I don't really want to put my neck on the line because I'm not entirely sure. We've been very focused on Queensland just for the time being, just to get these changes and these new charging options in. So hopefully they might provide guidance for other DNSPs as we generally share information over time. It might clear them up to necessarily some opportunities that they may wish to as well.
Excellent. Yeah. And while we're talking about different states, Xavier, is South Australia the only state that has implemented the vehicle to grid trials, or are we seeing any expansions this year?
No, that's correct. So South Australia Power Networks is the only DNSP that allowed for the installation of the V2G product. Having said that, I think one of the attendees to the webinar asked the same question. With the update of the Australian standards, the 4777, hopefully coming this year, I think there will be a broader acceptance of this technology in the rest of the states.
Yeah. And on the topic of vehicle to grid, there was a question earlier about what's the difference between vehicle to load, vehicle to home, and vehicle to grid. Just think of it this way: vehicle to grid means it needs to synchronize with the grid, and that requires a specialist piece of inverter technology. Vehicle to load, on the other hand, it just puts out 240 volts AC, and that doesn't synchronize with the grid. So if you tried to plug that into the grid, there'd be trouble.
100%. However, there are some vehicle to load capable EVs right now. I mean, I think they are super handy. You know, camping is a very popular activity here, and you know, you can go camping with these vehicles and power your little fridge, your little appliances, or recharge your technology or smartphone. So it's definitely, it's not the full scope of this technology, of course, a limited scale at the moment, but definitely handy for the time being.
Cool, yeah. Excellent. Now, Bryce, we had a question earlier about what's wrong with just charging off a PowerPoint. I think that picture of your fried extension lead is a pretty good example of why it's generally not recommended. How many do you have a handle on how many EVs are just charging off simple granny cables, as they were known, and how many get hardwired EVSEs, or is there a transition?
At the moment, the vast majority are using PowerPoint. I think the Electric Vehicle Council say something like 70 or 80% of people are still using PowerPoints. And a PowerPoint kept in good condition, or if you use an industrial type one, which has a screwed connector, that also eliminates or reduces the amount of free play or wobble in it. So it's just the weak point is where it comes in and out, and it just gets loose. And the least bit of warmth increases the resistance, which makes it just a positive feedback. So as soon as it starts getting a little bit warm, it gets really warm much faster. That plug-in socket I showed you was basically after one fail. It failed during one charging event. It was getting a bit warm and looking a bit odd before that, apparently. And then one charging event, it went from that to...
Yeah. And as to what's the decision point when people decide to move from a socket to a dedicated EVSE? I think once people have a need to put more charge in than what the 10 amp socket can provide, that's a fairly obvious answer. But also, if you've got solar on the roof and you want to try and make the most of that solar rather than exporting it, you want to put it in the car, you want to put as much in as you can while you can. And that really is only possible with an EVSE.
I also have a rule of thumb. If someone does more than 4 hours charging up a PowerPoint more than twice a week, you probably should go up to the next level. So if that was a 10 amp, maybe think about a 15. Or going to the full mode 3 hardwired charger to get that sort of options for solar, or for taking advantage of a short period of time for a tariff.
Cool. And Sanjay, are you finding that when it comes to strata installations, are you finding that there's a push to put an EV charge point in front of every parking bay, or is there kind of, let's just put, you know, some of them in and they can all share it? How are you seeing that pan out?
Yeah, I think 2 years back, most of the buildings were looking for shared chargers, right? I think it has gone towards we need a charger in every space. And that's where we see the industry will go, because if you look at NCC codes, new apartments, they do require that. And if, let's say, to an extent, you're competing in trying to sell your apartment, which doesn't have the infrastructure, versus a new apartment which has the infrastructure, it'll be hard yards. You just say, oh, they are two common power chargers and they are AC chargers, so you have to kind of share them. And we think that is going to be a difficult journey. So the conversation has definitely gone towards a private charger in every space.
And is individually metered electricity a common thing? And are you finding, or is it a shared electricity arrangement?
individually metered. I think that way. Individually metered. Let's say if you're going through the meter, that usually with your own power meter for the unit also, it works for probably 5% of the building, because obviously it doesn't work for high rise where your meter may be on 10th floor and you don't want to pull a cable from that. So 95% of the building will go through common power, and then you are metered for that usage based on whatever the building set as a tariff for the electricity.
Yeah, and given that, an increasingly larger number of Australians will be living in strata, it's certainly something we need to get right.
Yes.
Yeah. Well, there's a stack of questions piling in on the question box. Perhaps if Xavier, you could answer some that are on the open panel there that haven't been answered yet.
Will try my best. I've been answering several of them. I might
Depends how quickly you can type, but if you can answer them live, that would be great.
Yeah, absolutely. So the first one related to the Ocular Mode C. Ocular, obviously, EVSE manufacturer. I'm not familiar with this Mode C adjustable model they have. However, most of their EV chargers deliver 32 amps. So can I safely continuously charge at 20 amps? Again, I'm not familiar with this specific model from Ocular, but I would say it should be fine, because most of their models deliver the 32 amps from an EV charger.
Yes, and if I'm not mistaken, then there is the technology that exists within certain EVSEs to do load management. But if all else fails, the network can potentially cut you off.
There is a question for Robert. The next question I see.
I'm shuffling through them. Which one particularly is that?
752 from Dan Hawking.
752. Right. Let me get there.
What are the main differences you see in Queensland and SA grids?
Okay. Well, I'd actually say what are the similarities more than the differences. But I think that the main thing that other than the EVs themselves is driving South Australia and Queensland together is the sheer penetration of solar and rooftop solar. And as Bryce showed us, our duck curve that we experience on a very regular basis with regards to that deep trough in the middle of the day. So I'd suggest actually South Australia and Queensland are relatively well pitched in actually working out how do we get enough daytime charging happening? How do we encourage that? And basically get a double whammy, which is to get that minimum demand on our network being useful for customers, but then also hopefully that means you don't have to be charging your EV during those times of day, those peak evenings that are can be considerable problems for us in summertime with thermally induced load from air conditioning. So I'd say what the similarities, and we do talk quite a lot with South Australian Network with regards to what they're doing. We keep, I think, relatively close eye on each other.
Excellent.
And I was going to look at, there was a question from Gary about saying there needs to be a big possible government information education campaign to body corporates, because a lot are listening to the EV scare campaigns. I think AEVA have a place there, and there's an example of Norway and the Electrify America, and VW got their multi-billion-dollar payout, or instead of a fine, to produce an EV awareness and information and charging campaign. So there's definitely space for AEVA to do some work there.
Yeah, in fact, one of the most successful efforts that we're going to try and emulate here in Australia was that in Norway, they basically said it's illegal for a body corporate to unreasonably prevent someone from installing an EV charge point. And of course, there's a lot of couching around unreasonably. But yeah, basically, if they're just trying to be difficult, then that's not a good enough. It's not a good enough excuse. So it'd be really good to see something similar to that in Australia, and we'll certainly be working on that.
Yeah, the policy advice we did as the consultants to the ACT government included a section on right to charge legislation for body corporates and renting.
And I think like from our perspective also, what we have seen is when you talk to the body corporate, they say, oh, I'm not expected to buy a EV, right? So we don't need that. You may not need it, but when you go and sell your apartment, the next person may have a EV and he wants to have that. So it's like a discussion. You're happy with your diesel connection, but the next person may need an NPN, right? And need to get your building ready for that.
I've just, oh, sorry, Christine, your question, what is a duck curve? A duck curve is the amount of electricity being consumed on the grid during the middle of the day being quite low, but then ramping up rapidly in the evening as everybody gets home and starts turning on their appliances. And whilst networks are able to deal with a bit of that, they don't like to deal with a lot of that. And so, yeah, the goal of trying to charge as many EVs during the middle of the day and not charging them in the afternoon is definitely the goal here.
If you like, I could do a quick share and show a duck curve.
Yeah, if you like, yeah.
I do with the presentation, so I'll just do this and.
Okay, and then
So can you see that?
yes,
That's the duck curve there. I haven't actually closed everything up because I was answering a couple of questions, but you can see in the middle of the day, there's just the demand or the actual amount of power you need to put out from your generators is less and less because there's so much solar. So you get a big fat belly in the duck. So you got your tail of the duck, the belly of the duck, the neck of the duck, and the head of the duck. So it quite logically got called the duck curve.
Excellent. So John Smith, yes, you will absolutely get a copy of this Q&A. We'll include that with the presentation. There's a couple I can see that Bryce and Robert are answering questions in text. So if we can't get to it audially, we will. Very good question here from Malcolm. Why are vehicle-to-grid inverters so expensive? If a household inverter can make 5 kilowatts from a battery and have all the smarts for $2,000, how come vehicle-to-grid or vehicle-to-home inverters are $10,000?
I'll just jump in there live. It is true that the Quasar one, I think, was sold at that price. We don't have anything to do with that. It's basically up to the reseller that dictates the final price. Having said that, obviously with Quasar 2 being manufactured at scale, we expect that price to drop. But the RRP is not disclosed yet. We don't know what the RRP is going to be.
Yeah. And I do think that, yes, when the Australian standard AS4777 is updated to include inverters built within the vehicle, yeah, there's going to be a whole bunch of new testing that needs to be done to ensure that all the inverters are compliant. Yeah. Now, well, we've already hit our 1 hour for the webinar, and I'm sure people over East probably want to go to bed, and I certainly want to go home and have something to eat. Let's just grab one more question. Let me see. So there's a question here. Basically, every DNSP has inverter installation capacity limits at 10 kVA. How will a vehicle-to-grid charger fit in when the solar inverter is using most of that capacity? And we're seeing vehicle-to-grid chargers hitting the 11 kVA sweet spot. What can we expect DNSPs such as Energy Queensland to do?
Great question. And you're quite right at the moment. You know, those are the connection rules with regards to what you can put in from an inverter perspective, or that from a perspective of feeding back to the network. Look, from a vehicle to grid, considered certainly adding to the inverter capacity that is available through from a customer's premises. Happily, the answer to that is the ability to increase that opportunity around something we're introducing called dynamic connections. It may be something that others have heard about in dynamic operating envelopes, which will allow for increased capacity in individuals' premises for generation. But of course, there's no free ticket here. What that means is in a dynamic connection, yes, you can have more, but ultimately you'll be receiving dynamic operating envelope signals from the networks, and in time that'll be every 5 minutes, and they'll be giving you upper and lower margins for your connection to remain within. And being on a dynamic connection will mean that you'll have a electrical products, including generation and loads, that over time will be able to flex your energy use at that connection point and keep it within the margins of those operating envelopes that we send every 5 minutes. So yeah, look, good question, and it's evolving over time, and dynamic connections should improve that opportunity.
Excellent. And I've just got another question here from Malcolm, and I've started writing a response. I'll just finish that. Electrician. So the question, why has it been slow to implement vehicle to house? I'm assuming that by vehicle to home, we mean it's still not synchronized with the broader electricity grid. For the most part, that means you need to have a changeover switch installed in your meter box, and that means paying an electrician to rearrange your meter box. And that will that costs money, takes time. It's bread and butter for Sparkies, but it is. You may not have room on the panel, for example.
Yes, I was just installing a new charger, a Wallbox, in fact, that needed a kilowatt-hour meter to measure my solar and measure my incoming supply, etc. And being an electrician, I could, but I had to put in a bigger switchboard to make accommodate it all.
Yeah. Likewise, Hunter's got a question here. Why can't we use the generator standard like AS3010 for using vehicle to home with EVs? No, I don't think that would make any difference. Yeah, I think that seems reasonable.
It's got to do with it wasn't written with a car in mind. The same with 477. It just, yes, it's a battery, but a 4777 never was written with battery in cars in mind. So it just, by definition, you couldn't do it. And the generator standard, it's the same thing. It was never written with a car in mind.
Yeah. Yeah, and there will be updates and amendments to AS3000 and 4777 as we go along. So fantastic. Well, if nobody minds, I might say that we say thank you and good night to everyone here today. We'll try and, while we've still got the opportunity to answer these questions, we will, but I can certainly download a copy of the text and take the last couple of questions on notice. And otherwise, I'm going to remind everyone that, yes, AEVA will be at the Fully Charged Live event in Sydney. So I'll be there, and I hope to catch you there as well.
Yep.
Sorry?
I'll be there. I think, Xavier, you'll be there.
Yeah, I'll be there as well.
Sanjay, you'll be there?
Yes.
All right. Well, Robert, you better come down.
Yeah, hopefully, yeah. Get out of this stinking heat that is Queensland at the moment. What I can also say, Chris, is that if you're able to track all these questions, any that are useful for us, very happy to respond. And however you're able to manage them, get back to your members, yeah, happy to do so.
Excellent. No, we really appreciate it. We're really grateful to have everyone along to speak to this. Now, our next webinar will be in about 1 month's time. We're still tossing up which topic to cover. We're thinking about covering either the risk or perceived risk of EV fires, or training and competency in the world of EVs, working on them and that kind of stuff. Not sure which one will come up first. It depends on speakers' availabilities, but expect it to be in about a month's time. And of course, don't forget to check out the AEVA website. We've got lots of information and topics going up there all the time. For those of you who recently joined, thank you very much. We hope you stick around. For those who got a copy of the link and haven't joined yet, naughty, naughty, but if you join, we'll let you off. So thank you once again, and we'll put this up on the AEVA YouTube channel, and anyone with the link can watch the video. So thanks very much, everyone, and have a great night.
And don't forget the AEVA newsletter has just come out, which for members you can download via the front page of the webpage if your secretary hasn't yet let you know it's available.
Well, it's definitely there, and thanks for putting that all together, Bryce. Wonderful. We'll see you all later.
Thanks,
Thank
everyone.
you.
Thank you.
Bye-bye. Bye.